So today we're going to have Sanchit Juneja, who is a director of product at Booking.com. So he has multiple product managers who are on his team, and he specializes in big data and machine learning. So let's go ahead and welcome him.
Awesome. Can you hear me? Yeah. Something to be said about the animation, right? Yeah. Cool. So let me start. Cool. I jumped a few slides. Thank you so much for the presentation. I think you covered a lot, and I might not need to cover a lot more. So Sanchit here. As I was aptly introduced, I'm a director of big data and machine learning at Booking.com. This is me. I have around 18 plus years of experience. I'm quite old now, and I've spent all across the world. I started my career in the US. I started as a semiconductors engineer. Let's say vis-a-vis if you are a young org versus a big org like a Facebook or a Google or a Booking.com, etc., where are the better sources of investments and where is something that you can just skip over? Is something that I plan to take over. Obviously, it's great to see people again, although there are too many people here. Yes, there's something to be said on that as well. And obviously, we will discuss the typical data and ML ecosystem, right? But first, let's clarify the terminology. Right? There's a lot of words flowing around, but what do they actually mean, right? What is AI? What is ML? And what is deep learning? And I will throw two more words into it because we will discuss that later. What is LLM ops? What is FM ops? Etc. Right? What is artificial intelligence? Basically something that can do inferences, right? Right now we are carbon-based human beings. We are doing if A given B, B given C, we can tell if A given C. Similarly, if you can get that kind of intelligence in a silicon-based organization, that is artificial intelligence, as simple as that. What is machine learning? Basically data dumping. And there's nothing new, frankly, to machine learning. We have been studying neural networks for a very long time. They have been in academia for 60s. The only thing that has changed right now is compute is very cheap. So Moore's law has really kicked in. That's the reason you see a lot of LLMs kicking into the picture, etc. And obviously, deep learning is a smaller subset of machine learning. And yeah, just look at the picture. But let me get to the meat of the presentation, which is this, right? Any tech organization, any data organization worth its salt looks like this, right? You have multiple sources of data being ingested. Let's say hypothetically you are an e-commerce organization. You have a front-end web app, which is generating a lot of data across various ecosystems. Your data is being streamed into a central location, which is a second layer, data aggregation layer. Your data that is streamed into a central location is actually unblocking some kind of use cases, be it analytical use cases or operational use cases. And that is the third layer, which is the applicative layer, right? Any organization, be it Meta, be it Booking, be it a smallest startup that is trying to raise a pre-seed, looks like this. Obviously, there are nuances to it, and that's the nuances we will discuss. Let's get into it then. So there are various names to the layer. Let me go back then. Yeah, so the first layer where you see all the data sources being generated at, let's say, the front end, or if you are a back-end app at the back end, this is called the data formative layer, right? Data is formed here, data is ingested here, etc. There's a new advent of something called data ops. So there's a new layer which has come up, data ops, which a lot of big tech organizations are investing in. Then you have the data aggregation layer, which is, you might have heard a lot about data meshes, data lakes, etc. This is where the nuance comes into the picture. I will take each layer and I will dive deeper into it, and what kind of investments, let's say you as a young organization vis-a-vis you as a big organization need to make. And then you have the MLOps layer, which is basically the operational layer before you actually have machine learning deployments. Obviously, GenAI are SOTA ML models, so it includes GenAI. And then you have the applicative layer. An applicative layer could be analytics or machine learning, right? So we will dive deeper into each of these layers. So first, let's start with the data formative layer, right? As we said, right, data formative layer is where your front end is. where a lot of data is generated. Let's say if you are booking.com, you're going to booking.com, you're trying to book an accommodation, a flight, etc., etc. Everything that you're doing on booking.com is generating data. The kind of recommendation that you're seeing on booking.com are highly personalized to you because we are tracking you, we are tracking your user events, etc., etc. So how are we doing it? We are doing it through this data ecosystem, right? When you're here in the front end, your data is generating a lot. But where is the product value add in the front end, where the data is being generated? The product value adds is in a lot of experimentation. So if you look at the first set of experimentation, the first set of product managers that came up, they were the kind of product managers that used to experiment a lot on front end. Okay, what if I change this button from green to blue? What kind of experiment I can run, etc., etc. Will it increase in my bookings? There's a reason why Amazon is very proud of 2.5 clicks from intent to buy, because there is value to be made here. You can actually optimize it and you can actually move a lot of revenue because of front-end optimization. So there's definite value here, but it heavily relies on experimentation. So if you are, let's say, a young organization, let's say if you're very young, you don't really need to get into deeper into experimentation. But if you're, let's say, a big organization like a Google or a Facebook, your money, your revenue is generated on experimentation because there are 10 other competitors ready to take your lunch if you're not the best, if you're not hyper-personalized. So there is definite value here, but as you are seeing, right, we are getting deeper into the rabbit hole. Our tech ecosystem is getting complicated and more complicated. So this is not taken for granted because now there are tools out there that can actually give you experimentation. So let's say if you are a mid-size organization, if you're a scale-up, you don't necessarily go and build your own experimentation tool. You just buy one, right? And build versus buy is always on your mind because there's a lot of tooling already available in the industry. Let's move to the data ops layer. Yeah, this is a new area, right? There's a concept that I think most of us are ex-developers, right? If things become complicated enough, developers like to put an ops layer on top of it, right? It makes sense, it abstracts away the complexity of actually doing the core work. So if you remember, when development become complicated enough, we have DevOps, right? Git came into the picture, etc., etc. When security became complicated enough, we have SecOps. So DevSecOps actually came up with the complexity of our tech organization increasingly, right? Similarly, now data is becoming so humongous, especially if you look at data ecosystem the size of booking.com, which is one of the biggest data lakes. It's more than exabyte, right? You need to have a layer that manages away the ops complexity, and this is where data ops come to the picture, right? Again, if you are a young tech organization, you don't care about data ops, right? If you are a mid-scale organization, you don't need to build this in-house because there are vendors such as DataOps.live and Data Kitchen, etc., etc. They actually are here as well. So we can actually abstract away the complexity for you. But if you are, let's say, a big tech organization, most of the times you end up building this or maybe buying this as well, depend on in which spectrum of tech complexity do you lie, right? But this is a very new area. A lot of VC funding is actually flowing into this area as well. Now we come to the aggregation layer, right? And this aggregation layer has been around for a very long time because any kind of, let's say, the first generation e-commerce or the second generation SaaS startups, etc., everybody needs data, both analytics and machine learning. And although Gen AI is very new, machine learning has been around for a very long time, right? So aggregation of data, proper lineage, proper maintenance of data has been around for a very long time, right? But there are nuances to it, right? The most significant nuance here is when you aggregate all your data into one ecosystem, there are two kind of use cases you can unblock. There are OLTP data use cases, which are transactional use cases. If let's say, if you are an e-commerce organization, settling the bills per order is a OLTP kind of an execution. And then there are OLAP executions. OLAP is post hoc analytic reports. Let's say if you want to analyze during the last 1 week, how did you actually increase the sales or during the last 1 month, which is called OLAP executions, right? A typical big tech organization, when you come to bookings level, you start to determine, okay, there is a differentiation between those two, and it makes sense to differentiate the platforms. And if you get into big tech, these tech companies differentiate. There's something called an OLTP platform, where you will have, let's say, order platform, your identity platform, your privacy platform. And then you have something called the OLAP platforms, which is the analytics platform, which is the data exchanges, etc., etc. So this is the complexity that is very unique to big tech. But if you are, let's say, a young startup or a scale-up, you don't care. You just need a HTAP kind of a ecosystem, and correspondingly, a lot of tech databases that we have actually evolved to actually enable HTAP kind of use cases. So if you are, let's say we discuss MySQL and NoSQL, but there are a lot of in-memory databases that have also come up that will allow you analytics on the fly. So a tech at the core level is also changing because of use cases. So that is one complexity that you have here. Another complexity that you have here is how are you aggregating the data? And if you have heard of terms like data fabric and data kitchen, data fabric and data mesh, this is where a lot of nuance come into this area as well. So if you are, let's say, a young tech organization, you are thinking, okay, I will just dump data in a singular place, right? I will create a monolith, for the lack of a better word, and actually I will just extract away a lot of ecosystem. But if you are, let's say, a big organization like a Meta or a Google, especially with a lot of laws coming up on AI and ML, etc., data locking, geo-locking of data is coming into the picture. So a new kind of architecture has come into ecosystem, which is called a data mesh ecosystem, which is a decentralized ecosystem. Let's say India's data is only located near India's shores. China's data is only located near China's shores. And analytics can be maybe centralized or located. So there's a lot of activity always keeps on happening here, especially because of a lot of laws and regulations, etc., etc. But it has been a very well-funded area. Whenever I think, okay, this area has been well thought of, I see a new advent here. So this area is always worth looking at. And then we come into the MLOps layers, right? Obviously, GenAI is on a lot of mind. I think every second stall, every second vendor you see would have AI, GenAI, OpenAI on their board as well, right? But again, going back to our discussion, if something becomes complicated enough, we have an ops layer on top of it. Similarly, when ML became complicated enough, we have had an MLOps layer on top of it. In fact, the MLOps ecosystem has so much evolved then a lot of people who first built their MLOps ecosystem are now actually selling those ecosystems, like Nebari, but like SageMaker and like Uber Michelangelo, right? So if you are a big tech organization like Booking.com, we have a very big MLOps ecosystem team of our own. We build a lot of model training, model serving, a lot of nuances that are of MLOps in-house, right? But if you're a young tech organization, you are not hindered from using ML. You can just use Nebari, or you can just use SageMaker. You can use Arise for ML observability, etc., etc. And a lot of these vendors are very well established. So there is a new advent of this already. What has recently changed in this area is what the two terms I discussed earlier, LLM ops and FM ops, which is large language model ops and foundational model ops. Foundational model ops is a superset, LLM ops is a subset. Foundational model ops includes model ops for images, etc., etc., sound, and LLM ops is only for LLMs, right? With an existing ML ops ecosystem has 6 or 7 discrete components. You have a model training, model serving, model experimentation, model observability, and I think I'm missing model training. I think I'm missing one of the layers, etc., right? With GenAI, we are thinking about new things that have come up in the MLOps ecosystem. So obviously in MLOps ecosystem with GenAI, you can do prompt engineering. A lot of prompt foundation work has started to come into picture. You can do embedding management because you can actually call a public model but have a vector database in the backend to actually give a memory to a database. So that kind of ecosystem, and obviously you can do fine tuning of a model, hyper customize a model to your own needs. So this layer has always been there. But this layer has renewed investment because of GenAI. Again, if you are a young organization, you don't need to get into these complexities. You can just buy Amazon SageMaker. Or if you want to use GenAI tooling, you can buy an Amazon Bedrock. Bedrock is a new service. Google has Vertex AI, etc., etc. So a lot of these vendors who first built their MLOps ecosystems are actually now selling them as SaaS solutions. So something to be said about this layer as well. And then we come to the applicative layer. And this is a layer that has been humongous, right? Everything from self-driving cars, from drug discovery to e-commerce applications, etc., chatbots, etc., everything is happening in this layer, right? If you were asking me 6 months back, is there some standardization to this layer? I would say no. It's such a amorphous layer. Everybody is doing their own thing. But I think Gen AI and LLMs and all the craze that caught up with it have brought some standardization into this layer. So there is some amount of standardization, some amount of practicality of models, et cetera, et cetera. And obviously, models start with model evaluation. And as you correctly mentioned, a lot of investment is happening on model evaluation. How do you actually properly evaluate a model? Let's say if I want to check whether my user output can be done better with a Falcon 9 model or a Flan XSL model. So how do you actually test that? How do you evaluate the model on your custom metric? A lot of tech companies are actually investing into this. So Amazon has invested into something called Clarifier. Even Google has invested into a tool which is basically for evaluation. So there's a very hot area of investment. Basically, there is some amount of standardization that is coming, and a lot of tech companies are jumping into to catch into that revenue. So it's a very exciting area, obviously. One layer that we totally miss is the observability layer, right? And if you are a tech expert of any way worth its salt, you would know that observability layer is very important. Okay, no tech system worth its salt ever gets done without observability, right? So if you are an old techie like me, the only observability you know was system observability, which is the new relics and the likes. But obviously, with the increased advent of complexity of the ecosystem, new tools have come up. So there's a concept of data observability, right? A lot of vendors are coming up on data observability. There's a concept of ML observability, right? But I think if you look at a lot of ecosystem demand that vendors like us are asking for is maybe some combination, because we cannot have a singular tool for data observability, another tool for ML observability. So maybe this is a market gap that we have been asking a lot of our vendors. Why can't we have one singular tool for observability? But this is a very important layer that gets, this just moves away unobserved, but you cannot say that your ML model moved X amount of needle without any proper observability. So this is a very important part of the ecosystem. Just because it's such an important part, I gave it 2 slides, right? Observability, your systems cannot be leaky, right? If you are anywhere on the financial spectrum, if you are doing any SOX or GDPR kind of compliance, like big tech does, you rely, this is your heart and soul of your ecosystem. Cool. Just a final summarization slide, and I wanted to actually enumerate the kind of impact you can have and what kind of, because of the complexity of our ecosystem, how the ecosystem has changed. The first tech systems, the first tech ecosystem startups came up who were actually optimizing on the front-end layer. If you remember the first marketplaces that come up, etc., you're just selling something that somebody else has posted, right? And a lot of impact a product or a tech professional used to have was Y is equal to X, right? You can change a button on the front end and your revenue jumps by X, etc., right? But if you look at the next generation and the generation after, our tech ecosystems are correspondingly getting more complicated. And the kind of impact you have deeper down the rabbit hole that you're working also changes, right? So let's say if you're working in the data aggregation layer with SaaS startups, etc., your impact on the end consumer and the end revenue is Y is equal to Fx. Nowhere am I mentioning that the Fx is greater than X, but it can obviously be less than X as well, right? But obviously you have a level of abstraction, right? Similarly, now with the advent of Gen AI and LLMs, your impact on the customer can be Y is equal to F of X. So it's a rounded function, it's a circular function on this aspect. So I think the one thing that you can take away from this is, if you can actually create a very impactful, let's say, tooling or application at the ML layer, the kind of go-to-market that you can get is humongous, right? I think I read an article from Time as well, that the first e-commerce SaaS startup, which actually reached unicorn status, this is 1 billion status, took around 1,000 people. The first SaaS startup that actually took us to a unicorn took around 200 people. The first AI applicative startup that people are expecting would only take 3 people, right? So the amount of abstraction is humongous. I last coded 10 years back, but if I'm using Code Whisperer or any of those code abstraction tools, the code is highly optimized. So one of the biggest blockers to go to market has been totally removed, which is a big thing for all of us. Yeah. And yeah, as we discussed, there are some trend lines. As I said, application layer is humongous, but I think I would be standing corrected because of Gen AI. There's a lot of standardization that is at least coming to this layer. Does applicative layer need PMs? I don't know. Right. So I think we have not seen the value of moving metrics right now in applicative layer, but maybe something can be done. As always, the answer is statistically variant. And that's me. I hope I didn't bore you to death. It was not a post-lunch lesson, so I'm hoping people did listen to it, and I will call it quits then. Yeah. Do we have time for questions? Ah.
We'll try again. Please ask questions. Let me bring the mic to you.
Hello. Very nice talk. Thank you. I mean, you were discussing things on a very, very high level in the talk. I was wondering whether you can provide maybe some examples from Booking.com, how you do certain things, where you're putting your emphasis. I don't know if you can talk about these things, but perhaps give maybe some insight.
I can. I was wary of actually getting into too much of weeds, right? Obviously, I had 20, 30 minutes. But a lot of choices that I discuss are the choices we took discussions on and we took decisions on in real life, right? So this is reflecting the real life decision tree. This is not a hypothetical tree. This is what we actually decided on, right? Let's say, for example, when we say data lake versus data mesh, there's a very valuable call we did because we are a multi-geographical organization. We had to go for data mesh, right? When we discussed separation of our OLTP and OLAP concerns, there's a reason why we did it. There's a reason, but there are also counterpoints. Let's say if you look at something like Airbnb, they didn't do it, right? So there are pros and cons of each of them, right? So you take the judgment calls with the context that you have. And it's very difficult to convey the context in a 20, 30-minute call. Yeah.
And maybe a second question to follow up to that. What are the major pain points in that pipeline that you mentioned at the moment, I mean currently?
I think the biggest pain point is the speed of industry's evolvement, right? Let's say the initial part, the data formative layer to the aggregation layer, I think it is pretty standardized, right? A lot of water has went under the bridge, and I think we are relatively confident that we have taken the right decisions there, right? It's the latter part, which is the ML and MLOps layer, which I think everyone is figuring out, right? Even we don't know. We have a very strong MLOps ecosystem. I think Booking has the most horizontally scaled MLOps ecosystem in the industry. We do more than 200 billion predictions per day, right? So we know how to do MLOps, right? But how to do LLM ops? I think nobody knows that. I think that is the area which is very greenfield, and that's where we are not very aware what to be done. Yeah.
Excellent. Thank you very much.
Cheers.
Any more questions? Anyone?
Yeah.
Just raise your hand.
No worries. Yeah. Cheers.
Okay.
Thank you so much, folks.
Thank you.